Hello everyone, today I will show you a presentation about functional programming and is related to the fourth assignment of Computational tool for Big Data. So the schedule will be an introduction of functional programming, an introduction to Haskell and his algebraic data type, and one library based on Haskell for machine learning, and the final is evaluation. So nowadays we are generalizing for different functional programming languages in data science such as Julia and Clojure. In this presentation I will show you an example of pure functional programming languages such as Haskell and then a machine learning library for Haskell that use the algebraic data structure for making the learning algorithm more efficient. The biggest benefit of functional programming is that in a functional programming there isn't assignment, but bindings between value and variable. How you can see in this first line. Another benefit is the absence of the side effect. So when we evaluate two different functions with the same data, the result it will be always the same at the beginning and the end of the program. Allow less time to check the correctness of our program. Other benefit will be brevity, because the code can be more concise, and the function in a functional program doesn't create an iterator variable to be the center of the loop, so this and other kinds of override are eliminated for our code. The major benefit is concurrency. It's easier to do with functional programming because the compiler is taking care of the most operation, which is used to require manually setting up state variables, so like the iterator in a loop. Functional programming are naturally thread safe, and given the rise of multi-core hardware, this is of uttermost importance. Performance benefit can be seen in the context of single processor, like lazy evaluation. We can use the data structure before the space for it is allocated. And functional programming language is concise, but it's not so easy to understand, how you can see from this image. And there is an inertia from the company to adopt this type of language. But there is some movement like F# that is now supported by Microsoft. Other on functional programming is that exists the concept of first-class function, that a programming language that function as value. One of the most consequences of having first-class function is that you should be able to pass a function as an argument to another function. The latter function is now high-ordered. It is a function that takes a function as argument. Recursion is used in opposite to iteration. There is also the concept of referential transparency. Is the concept that if an expression is said to be referential transparent, if it can be replaced with its value without changing the behavior of the program. And also there is some concept inside the compiler of Haskell that is the deforestation concept. Well, a program transformation to a tree structure allow the program to run faster. Another concept from the Haskell is that is used from Facebook for create a series of rules during the checking of our message in the platform. So Facebook can view if there is some scam inside the platform that posts some not so clear post. Now I will present a library that is made by the PhD from the University of California, University of California, Riverside, and this is based on Haskell, and you use the algebraic properties of learning model. The goal of this library is that make the machine learning technique easily usable by not specialists. And how is done? Characterize a learning model according to their algebraic structure. And the basic idea is that when a user understands the algebraic structure, then she automatically understands all the instances of the structure. Unfortunately, start use it is not so trivial. For me, it's not so trivial. and we should have a basic of algebra for going deep of this concept. The algebraic data type, for example, is in the right side. So we can have a monoid if we have an set, an associative binary operation, and an identity element. The interesting thing is that if we have an associative binary operation like multiplication, adds, or concatenation in the list, we allow this data structure. We allow the operation. This operation can be done in parallel, and this with the rising of multicore is our things. After that, a group is an monoid with an inverse element, and an abelian group is a group with the commutative binary operation. Other concept is the homomorphism. This is the definition from one paper that I have studied that is presented in the HLEARN library. And if a model M that we can think about a probabilistic Bayesian network, we are trained to learn for some monoid, then our batch trainer is a homomorphism if for all data set we have this type of operation. So homomorphisms are a generalization of linear function. Both are particularly nice to work with. And the basic concept inside HLEARN is that the learning model is an instance of home trainer data type. Home trainer class offers a data point type where we can save the input, and an utility function for learn the model, such as batch trainer and online trainer. Every instance of home trainer, the learning model, obeys 2 for laws. The batch trainer must be a monoid homomorphism, and the other can be summarized, and no matter how we train our model, as long as we use the same data point, we will get the same model. And this is the concept behind the functional programming. So is that there isn't a side effect. And another one things about HLEARN and Haskell is that if you can write an algorithm for a particular algebraic structure, we can use this algorithm for the other instance that implement the same algebraic structure. Here I will show you an example of 3 algorithms that take advantage of an algebraic structure. First, the fast cross-validation. The cross-validation is a technique that allows us to avoid overfitting. Overfitting happens when our trained model performs well on the input data points but generalizes poorly to other data points it hasn't yet seen. When analyzing data, we must run a cross-validation procedure every time we train a new model to ensure we are not overfitting. Typically, increasing the number of folds makes for a better generalization estimation. This section is expensive in large data set, so we have that the complexity is high, is O and K. But in our paper, in the paper that I have studied that is present HLEARN, is present a new version of cross-validation that is more generic. It takes advantage of an algebraic structure called monoid, as I presented before. So monoid and cross-validation scales better, and this is the difference. So we have a prefix function and on a first floor that is the training loop that made all this type of training for all the set, all this subset 1 time. After that, we calculate a prefix for each row, and this is the prefix. After that, calculate the suffix loop that calculates this type of subset, and in the end, for the testing loop, we have that if we want to calculate our error between the training set and the test set, we can do this one in not as showed before, so run for all this data structure. But we remember that we have done first for all the tests, and after that for the key times that we want to do the cross-validation. So this is less expensive. After that, another algorithm is another concept is the parallelism, and it's well known that the parallel complexity class NC can be defined in terms of programs over finite monoids. One example can be the Google MapReduce, is a monoid computation, and the training function that can be implemented in parallel is a monoid homomorphism. So the model we get from training a parallel is the same exact model we would get from training with a single machine. And this is a well thing. At the end, my evaluation from the study of this library is that my experience with Haskell is not is not so easy, because I've spent a lot of time to study Haskell, and I think that in 2 weeks I don't have know very in deep how it works. And I think that from the point of view of Gartner hypercycle, I am near here. But from my evaluation about HLEARN is that it exploits the algebraic data structure in data and learning, and we can derive better algorithms, as I showed you before. And is a different way of thinking in terms of algebraic structure. HLEARN, besides, is not mature, I can't suggest this to for implement some business future with the Haskell, and start to work it is not so trivial as Python. So I suggest to everyone for become a better data scientist, but not to someone that won't start immediately to work as Python alone. And at the end, I want to suggest some other book that I don't have used, because typically the first one have a good list of well-known topics in data science, and is a cookbook. So there is a list of programs that is yet done that I don't want to do a presentation during use the work of other people. But for a beginning, is good work, because there is a concept of MapReduce and a lot of examples. Another books is Learning Haskell Data Analysis, but unfortunately this is theoretically, and talk about the stock market, and for me starting with it is a bit complicated. And at the end, I have tried to read a bit about Haskell financial data modeling. That is a good introduction for the beginner data scientist, but not an introduction to Haskell. So I have preferred to start with read the paper about HLEARN, and use the big online site for read about Haskell. And this is it. Thanks for your attention, and goodbye.